This session covers how to create a K-joint. Kinematic joints. Kinematic joints are categorized as lower pair joints, higher pair joints, and compound joints. Lower pair joints. Lower pair joints has area contact between two mating surfaces. Because of this area contact, there is lesser contact stresses generated between mating surfaces. And this is animation which is an example of a lower pair joint. Screw and bolt. Example of lower pair joints are revolute joint, cylindrical joint, and ball joint. K joint is a revolute joint which is having single rotational degree of freedom. Cylindrical joint has 2 degree of freedom, and ball joint which is having 3 rotational degree of freedom. Higher pair joints. Higher pair joints has point or line contact between two mating surfaces. Here we can see cam and follower. This cam is having a single rotational degree of freedom, and follower is having a single translation degree of freedom. So cam and follower which has 2 degree of freedom. So here in mating surfaces there is point or line contact, so there exists more stress between mating surfaces compared to lower pair joints. Compound joints. Compound joints are combination of higher pair and lower pair joints. These rollers which are having revolute joint which is a lower pair joint, and between ball and roller there is a surface contact which is a higher pair joint. So it is a combination of lower and higher pair joint and ball and roller bearing joints are called as compound joints. This is the FE model of bucket and front arm. We need to generate K joint between bucket and front arm. Steps to create KJOINT2. First, we need to create a spring using 1D elements. Second step is to apply property to spring to it. Create P45 KJOINT2 and select type of joint required. In property, there is a card image P45 KJOINT2. We have to select P45 KJOINT2, and within that property there are many types of joints like cylindrical, spherical, revolute joint, etc. We need to select type 2 to indicate a revolute joint. Third step is to connect spring 2 to finite element model. Final step is to assign property K joint to spring 2. In second and third step, we have created a property that has to be assigned to spring 2 here. This is a FE model of bucket and front arm. This is a sub-assembly part of excavator. So we need to generate spring between front arm and a bucket. Here we can see rigids created for separately for bucket and front arm. There are 2 rigids for bucket and a single rigid for a front arm. We can see that there are free rigid nodes. These are the dependent nodes of rigids where we need to generate a spring. So now I will create a spring, create component for spring, name it as spring. Go to 1D, springs, spring 2, node 1, select node 1, node 2. Now spring is created between rigits. Same way we need to create another spring on the other side. Select spring 2, node 1, node 2. So we have created springs. You can see red color springs. So now we need to apply property for the spring. So now I'll create property, name it as KJOINT2. Go to card image, select P45 KJOINT, P45 KJOINT2. Now select type of joint. Here there are many types of joint like cylindrical joint, spherical joint and revolute joint, etc. So type 2 indicates a revolute joint. We need to generate a revolute joint between bucket and front arm. So select type 2. Now we need to apply positive and negative stopping angles. So always we need to apply this angle in radians. So for example, if you need to rotate bucket by 30 degree, convert that 30 degree into radians, becomes 0.52 and apply here. I'll give negative stopping angle as 0 and positive stopping angle as 0.52 radians. And here in property, there are three parameters which we need to define. First one is type, type of joint, say type 2, then positive and negative stopping angle in radians, and card image as P45 K joint 2. Now property is created. This property has to be assigned to spring. Then only spring works. Assign property K joint 2, apply, OK. Now the K joint 2 act as a revolute joint. Now I am going to show how this K joint 2 works. We have given a positive stopping angle of 30 degree around y-axis. So it's rotating for 30 degree around y-axis.